So this is section 6.3 in Precalculus, and we need to kind of talk about the idea of degrees and radians. Now that you know angles can be measured both ways, degrees and radians, let's kind of think about what that looks like on an XY axis. So remember when we talked about degrees, we said that you start over here at 0 degrees, and if you're rotating in the positive direction, then when you come up here through the first quadrant, that's going to be 90 degrees. And if you keep going to the second quadrant, you're going to be 180 degrees, because remember, every quadrant is another 90 degrees. And so if you come down here, you're at 270. And then one full circle all the way around, you're back to 360. If I said, like how far is halfway into the first quadrant, well, if I went exactly halfway, that would be 45 degrees, right? Because that would be halfway between the 0 and 90. Okay, so how does that compare when we talk about radians? Well, remember how we said for radians, we know that pi equals 180, right? So pi is 180, so that means over here at 0 degrees, that's going to be the same as saying 0 radians. So 0 is kind of universal, right? But if pi is 180, then all the way on the other side where it would have been 180, that's going to be pi. And so think about it. If it takes 2 quadrants to be 1 full pi, then that means each quadrant equals a half pi. So I'm going to put here each quadrant equals half of pi. And instead of saying half of pi, we tend to say pi over 2, because that's the same as saying half of pi. So if every quadrant is half of pi, then up here at the end of the first quadrant, that's going to be pi over 2, or half of pi. The second quadrant is pi, so then I have another half, so that would be 1.5, but instead of saying 1.5 or 1.5, we always use improper fractions, not mixed numbers. So we would say 3 pi over 2, that's like 1.5. And then if I had another half, then I'm back over here to 2 pi, right? So if like at the top where we talked about the whole 45 degrees, so if I went exactly halfway into the first quadrant, we're not going to say 45 degrees, but think about it. If I start at 0 and then one full quadrant is a half, well, what would half of that be? Wouldn't it be like a fourth of pi? So this is pi over 4. So that makes sense. If you have a fourth and then another, I'll say here, a fourth and then another fourth, it makes sense that that gets you up to a half of pi. And if I really wanted to keep going, I could say, okay, if I divide this in half, there's another fourth and another fourth. So it's kind of like saying it takes 3/4 to get over there into the second quadrant. And then if I have the 4/4, I'm back over at 1 pi. Just to kind of have you think of it in terms of fractions. And I know that for some of you, fractions seem so foreign, but you've got to kind of get this critical thinking piece down, because again, it's going to make your life so much easier this semester. Okay, so if I want to think through not having to switch to degrees every single time to know where it is, then here's kind of what we're thinking. For each radian measure, you're going to ask yourself the question, is the fraction between, so think about what we said, every quadrant is a half of pi. So the first quadrant is going to be, is the fraction between 0 and 1/2, right? Because that would be the first half. For quadrant 2, you're going to say, is the fraction between 1/2 and 1, because every quadrant is another half. And when we say 0 and 1/2 and 1/2 and 1, what we're implying is 0 pi and half of pi, or half of pi and 1 pi. It's just that we're not going to think pi every time. We're just thinking in terms of fractions. So for the third quadrant, we're going to say, is it between 1 and 1.5? I'll say here 1.5, but remember, instead of writing it as an improper fraction, as a mixed number, we think of it as an improper fraction. And then for quadrant 4, is it between 1 1/2, which is 3/2, and 2? So that's what you're thinking out loud. So for number 1, sketch the angle in standard position. I don't want to have to change this into degrees in order to know how to sketch the angle. You're making your life way harder than it has to be. So just think about it. If here I am at 0, so I start right here. If I go all the way to pi, then I'm all the way over here. But isn't 3/4? So there's a half, and then another fourth would land exactly in the middle right there. So this is 3 pi over 4. It's 3/4 because 3/4 is between a half and 1. Okay, for 7/6. So just think about the fraction, 7 over 6. Yes, that's like 1 1/6, but all I'm thinking about is it's a little more than 1. So here I start. If I go 1 pi, I'm here, and then a little more is going to land right here. So this is 7 pi over 6. Okay, 5/3. Think about the fraction. 5 over 3, it's like 1 2/3. So I start at the positive x. If I go 1 pi, I'm here, but another 2/3. Well, if I go to here, that's 1 1/2. Isn't 2/3 more than a half? So I need to go a little bit more. So I'm going to land right down here in the 4th quadrant. So this would be 5 pi over 3. Okay, so for number 4, so I'm going in the negative direction. So I know I'm going this direction, but I'm only going 1/3. Well, that's less than a half, right? So I'm only going to land right here. So negative pi over 3. Okay, negative direction. So I know I'm going this direction. 11/6 is the same as 1 5/6. Isn't that just a little less than 2? So here's 1 pi, and then 2 pi would be all the way, but I'm going to stop a little bit short, 1 5/6. So that would be negative 11 pi over 6. And then for number 6, negative 2/3. So I start right here. So that's a little less than 1, right? So if I was going in the negative direction, but I'm not going to go all the way to 1 pi, I'm going to stop a little bit short. So this is going to be negative 2 pi over 3. Again, I'm not getting too hung up on where in the quadrant you land, as long as you land in the correct quadrant. Now, I know you're thinking through fractions, so this is requiring some thinking, but doing it this way is in comparison to having to change it to degrees and then go from there. So like, for example, let's say on number 3, if I'm not doing this kind of fraction method, I'm thinking to myself, okay, 5 pi over 3, 5 times 180 over 3, and if I simplify, 3 goes into 180, 60, so 5 times 60, so it's actually 300 degrees. And then you would say, okay, 300 degrees is going to be past 270 and into the 4th quadrant, and then it's going to stop in the 4th quadrant. So I don't want you to have to change to degrees every single time. I know degrees, for whatever reason, because they're not fractions, they seem more familiar to you. But we really need to start switching over to radians, because as you go further in math, and specifically if you were to take calculus next year, we only talk about radians. We don't talk about degrees. And so we're kind of in that transition year, but if you force yourself to think about fractions, radians is not going to seem hard. In fact, we're going to get to some things where radians is going to be a little bit easier, actually. Believe me. All right, so let's keep going. It says find the radian measure. So I don't want degrees, I only want pi. Find the radian measure. Remember, radian means in terms of pi, of a coterminal angle to number 1 through 3 above. Okay, so remember, number 1 was 3 pi over 4. Number 2 was 7 pi over 6. And number 3 was 5 pi over 3. All right, well, think about it this way. Remember, coterminal means same terminal side, okay? And what we did last time was, sorry, let me bring this down. what we did last time was we said, well, if I want a coterminal, I can just add 360 or subtract 360, okay? So if I have 3 pi over 4, I don't want to add 360 because 360 is degrees. What would I be adding if it were radians? Well, I would be adding 2 pi. So if I have 3/4 and 2, that would be 2 and 3/4, right? 2 and 3/4. But remember, we don't like mixed numbers. So what would that be as an improper fraction? Well, how do you change mixed numbers into fractions? Wouldn't you do, remember, don't you do 4 times 2 is 8 and then plus 3, so 11 pi over 4. Let's try one more. If I have 7 pi over 6, and let's say, I mean, again, you can either add 2 pi or subtract 2 pi, whichever you want. Let's just try subtraction because it's different. So if I subtract 2 pi, so 7/6 minus 2, that's what we're really doing. Forget the pi's, 7/6 minus 2. And if I'm going to add or subtract fractions, I have to think common denominator, right? Well, so 7/6 minus, isn't 2 the same as 12/6? So isn't that going to come out to be -5/6? And we're talking pi. Okay, so you do have to know how to add and subtract fractions. Okay, that was section 6.3.